Welcome to our webinar. Hopefully everyone can see these slides. Today's webinar, of course, is about the specific use case for our tool set on healthcare networks. Healthcare vertical or problem space involves a number of unique challenges to those working within it, especially in IT and IT security. Some of these are listed here. We have, of course, rapidly changing technology and pressure for adoption. The healthcare space is highly competitive, and lots of technologies are introduced almost continuously, which require involvement of IT, whereas in the past in healthcare, these often were outside of IT's purview. The fact that technology itself in the healthcare space is increasingly networked requires IT's involvement and assistance as well as security. There are a lot of expensive stationary and mobile devices deployed in hospitals and clinics, which IT is often required or leaned on for inventorying and paying attention to where they are, since they are network connected. There are also many high-risk pieces of equipment in hospitals that are of a particular note when it comes to the security risk picture. An example would be automated pharmacies. These are devices that look like vending machines that are full of drugs, and they are used by the hospital staff so that a doctor can write a prescription on a computer using a program, and it gets sent to the automated pharmacy, and then a member of the nursing staff who's charged with actually caring for the patient in question can go up to this pharmacy, type in her code or his code, and receive the drugs dispensed from it automatically. Something like this, of course, is an obvious target in an environment, and presents a tremendous risk, of course, for the healthcare community to try and protect it and keep an eye on it. The need to provide access to guests, there's a tremendous pressure for this as well. At first, I would, having worked this vertical for quite some time, I'd say hospitals tended to resist this, but of course patients and patient guests who were spending a lot of time with patients and a lot of time waiting as hospital networks grew, put a lot of pressure on hospitals to give guest access, and most hospitals do so today. So this is, of course, quite challenging. How do we make sure that those guests are doing, what they're supposed to, and they're not trying to do anything untoward? How do we make sure that their access is consistent and that they can get what they want, that they're able to surf the net, that their protocols are supported, et cetera, is challenging. Of course, there's a need to provide access for transient professionals, and in healthcare, this is a lot more challenging and a lot bigger need than in a lot of other businesses, because in healthcare, the transient professionals are often doctors or visiting surgeons. They're being paid quite a bit of money. They tend to be rather demanding, and the IT staff can't really push a lot of rules on them. They also tend to walk in the door expecting the healthcare entity to support any device they might already have. They're very resistant to being told, here, you need to use this particular tablet when you're here, this phone, and so the BYOD is a very, very big deal in healthcare. And that next bullet's all about that. We've got to provide access that's open to any device, anywhere, at any time, all throughout the healthcare network. You need to be able to monitor and differentiate access to devices based on device type and application. So, things like image servers have to have guaranteed bandwidth if we're going to be able to move things like electronic x-rays around to doctors' desks and get them to them in a timely fashion. The regulatory environment for healthcare is enormous and very complex and often murky and not well understood. It took many years before healthcare companies were, at least partially convinced they had a handle on how all the HIPAA rules affected them from an IT standpoint. And now with the ACA being such a large piece of legislation, it's going to be many more years before folks figure out how that affects IT. It's just a huge unknown. The fact that the healthcare industry is really, focused on patient care enormously magnifies the risk picture. Very few other businesses have the same level of risk in IT operations that healthcare does, because people's lives are depending on decisions made in IT. And really, a lot of these problems boil down to visibility issues. What's going on in the network? What's touching what? What's going on at what time? What are my servers doing, et cetera, et cetera. We really need to be able to see these things to be able to affect them and effectively deploy policy. So examples, we have the example of monitoring medical devices. As I mentioned already, a tremendous number of devices now in the healthcare environment are on the IT network. They're either plugged directly into a port or they are more often wirelessly attached. And this includes all sorts of devices that you may not expect if you're not in the healthcare world, including infusion pumps, dialysis machines, heart monitors, and again, the previously mentioned things like automated pharmacies, even things like medical robots, inherently rely on the network and on networked applications for their operation and the way that they do what they do. So these are very, very challenging. How do I monitor these things? Where's that crash cart? The hospital spent $300,000 on it and no one can find it. Is it active? Is it running on the network right now? Who was the last one to use it and log into the computer on it? All these questions are common in a busy hospital. What devices on the network are touching the infusion pumps? Are those infusion pumps only being talked to by the server that serves them, or are there other devices on the network that are actually touching them? What protocols are they speaking? Is my automated pharmacy secure? Are network access policies that I've deployed to secure it working? Or are things getting through to them that shouldn't be? Is the patient guest access sufficiently isolated from the rest of the network? Are guests basically locked down to their own VLAN and only allowed internet access, or are they able to probe about my internal environment? Is that patient's bored, angry teenage son who doesn't really want to be there, the guy that probably went to DEF CON last year and downloaded some hack tools, is he trying to hack us? What's he up to? He's got his laptop every day and he's typing away. Is he only on Facebook, or is he doing something else? And can this visiting neurosurgeon with his iPad and these apps that we've never seen before, can we accommodate him rapidly and get him up and running without causing any problems? How do I manage bandwidth, especially if I have multiple hospitals and I need to be able to move large files back and forth, or real-time protocols if I'm doing some kind of e-learning or I'm supporting voice? How do I know that the policies that I've implemented for quality of service and such are working? How do I make sure that images are delivered? How do I know what's using that expensive maybe man bandwidth between my hospitals in a city? How do I know what's using those links? Which clinics are utilizing the network the most effectively? Clinic bandwidth sometimes can be challenging. How do I know that the clinics are properly using it? And how do I make sure that employees at the clinics that maybe aren't so busy aren't doing streaming, off of a streaming media site and eating up bandwidth that I need for patient care? And finally, how do I track access to regulated information? Patient data on the healthcare network, of course, is protected by a variety of laws, the most prominent of which is HIPAA. But how do I ensure that this information is properly protected? How can I show who's touching it? How can I respond to an audit? How can I ensure compliance with any current or future regulatory requirement for critical systems, so that I'm ready in case something bubbles up out of, for example, the ACA that lays a new requirement on IT? How do I make sure that my infrastructure is flexible enough to be able to deal with this? And again, this audit, the ability to respond to an audit quickly is really, really critical. Often in any IT environment, when one needs to be able to prove, for example, that a certain set of systems are only accessible from another particular set of systems that are part of a policy and nowhere else, and show that no one else who isn't part of that policy is able to access those systems can be very, very difficult. You know, often we're stuck in an exercise of pulling up access lists and showing network diagrams and maybe deploying sniffers or probes around the protected devices, and then trying to compile a list of access over some period of time. And again, when you're preparing for such things and responding to them, that can take weeks of preparation in some cases. So is there a way to set up a monitoring solution that isn't so invasive and that can let me respond to these audits very, very quickly? The big picture here, of course, is how do I ensure that my IT operations and the underlying infrastructure and my purchasing decisions that I've made are positively impacting my patient's medical outcomes. Really the bottom line here is patient care, and want to make sure that, that what we do in IT supports that primary goal of the medical infrastructure to properly care for patients and help them get healthy and get on with their lives as quickly as possible. And this, again, can be quite challenging in the healthcare environment with IT. Of course, on top of that, we still have to deal with all the normal IT issues that are common to all business. You have network monitoring and management that has to be done, securing other assets and data in the environment, dealing with the advanced threats that we're hearing about all the time. How do we make sure, you know, all that normal stuff is under control, that no one's stealing data and getting it out of the hospital, that you know, people aren't, there are no worms active, no one's touching a botnet, et cetera. So all those regular threats are still a problem. How do we ensure that AV is properly, you know, working and deployed, et cetera? So all the normal issues facing any IT department are also, of course, still of large concern in healthcare. And again, this all boils down to a visibility issue. How do we see what's going on in the network so that we can know, so that we can make good decisions about current and future policies and react to issues rapidly? So what do we think of? We think of providing visibility in an IT infrastructure, especially in a security standpoint, but for network monitoring in general. Of course, we normally would collect logging information from a variety of devices in the network, but this rarely gives us a picture of what's actually going on between hosts on a network. And so usually in a security context, we think of providing visibility as something that we need to deploy probes to do. So probe technology can be something as common as IDS tools, where we're deploying these intrusion detection sensors in certain places in the network, and then those things act as like super sniffers with a rule set, and they look through data for particular patterns and then make reports accordingly. This can also, you know, go all the way to the extreme of full packet capture probes that are deployed in the network that grab every single data byte and store it. So that it can be used to, you know, dig in and see what's going on and maybe do some kind of alerting. And these share a problem, and that problem is one of very high operational and capital expense. Essentially, when you begin deploying probes, most companies, and healthcare is no exception, end up finding out that they simply can't do them everywhere. They normally aren't deployed out at things like the access layer. They're just too expensive to put all over the place. In the core, where a lot of risk is perceived, deploying a probe on a high-speed links can be very expensive. 10 gig IDS or capture device can cost $100,000 or more. There are only a few vendors making devices like this that have 40 gig interfaces, and they're around $500,000. And so when you're looking at that type of expenditure, you really have to triage and choose where you're going to get your visibility. And so as a result, you're going to miss visibility in areas where problems may begin. For example, back at the access layer with your guests, or or with internal hospital personnel that might have brought an infection in on their laptop, or maybe they're a disgruntled employee and they want to cause problems or steal something. We're going to miss where these smaller issues start and begin to snowball. We also may miss things out at remote clinics, again, because we simply can't afford to deploy these technologies all over the place. And operating them and monitoring them is very expensive, as well as the fact that in a lot of cases we don't get a lot of history with them. So if we are doing a forensic investigation and we need to go back in time and look at what happened perhaps yesterday, if we're doing full packet capture, often we don't get more than 8 hours or so, and if we've spec'd the system for longer, it's cost a tremendous amount more, usually a lot more than we expect. We talk about that kind of monitoring the way we would talk about essentially wiretapping. So wiretapping of a phone line is very analogous to this traditional monitoring scenario. In a wiretap situation, we plug a lot of expensive devices into basically an environment. We get a feed from the phone company for the target's phone line. We have a variety of personnel that are on shift 24/7, ready to listen to the calls. We record all the calls, every word spoken, and review them. And if you can imagine what this is like, there's a lot of expense for a tiny amount of payoff or expected payoff. Most of the time, if you're listening to a target's phone line, you are hearing things like that target complain about their boss and how much their job sucks, or they are bragging about their kids' soccer performance at some match, or their spouse is calling them, telling them to bring milk home for dinner. And you're just waiting and waiting for something important that matches some particular thing that you were interested in, which may or may not ever come. In the meantime, you spend a tremendous amount of capital and are spending a tremendous amount of operational resources to do this monitoring, to record all this mundane data, most of which you're never ever going to use or go back and look into. There is another way, however, to get value out of someone's phone conversations and attribute issues to them and find malicious activity, and that is to obtain their phone bill. With someone's phone bill, you can actually tell a lot. You can, see who they called. You can see how long the calls lasted. You can see when the calls began and ended. If you're pulling this from a cell phone company, you can also get maybe the location of the user. And in fact, if you expand your search and include the phone bills of the folks that this person talked to, I can now start to see things like their community of interest, who they're friends with, who they spend the most time with, who they don't like to talk to. I can make all kinds of inferences if I apply the appropriate algorithm to this data. And if you've been paying any attention to the stuff with the NSA lately, this is what we call metadata. This is very, very useful, and the beauty of it is I don't have to listen to any conversations to know whether or not, for example, my target called a known criminal and maybe violated their parole. I don't need to know anything special to know whether, for example, it was a wrong number or whether they actually talked to that person, because I can tell by how much time they spent. And the real beauty of this is I did not have to deploy a single spec of extra hardware or incur any extra capital expense to get this, because this functionality is built into the telephone company's network already. It's already part of their investment. All I had to do was call the telephone company and ask for it, and I could get it. So it's already being produced. This data is already latent in that network that's already been paid for. So it's very, very simple and very quick payback for folks using this kind of data for this purpose. NetFlow technology, which is a telemetry source available in your networks generally, is perfectly analogous to this phone bill. Now, NetFlow is the network's phone bill. And NetFlow will show you which host called which host, or who called who, how long it lasted, when it started, when it stopped for each conversation, what language they spoke, that is port and protocol, how much data was transferred, what the data rates were in both directions. and a number of other pieces of information. For example, the quality of service data on each interface that the data crossed, or time to live information, or if you're getting flow from things like firewalls, you may get permit or deny actions, you may get URL data. So there's all sorts of great information available in NetFlow that does not require you to listen to every data byte. Also, this data is structured, it's easily compressed and stored, and so essentially we can have very, very long-term histories available to us on the order of months, or in some cases even years, rather than just hours as we would with packet capture. It's also very easy to search and sort and dig through. And like with the telephone bill, if we apply the appropriate algorithms to it, we can tell a lot. We can tell who your host talks to. We can tell what protocols your servers offer. We can tell if your host behavior changes by how their flow changes. And also, like the telephone bill, this data is available in the network you've already deployed. So generally all you have to do is go and turn flow technology on, and you get this data. So it's part of an investment you've already made. No need to deploy probes to get real, true end-to-end visibility. And so now again, if you have, for example, a Cisco infrastructure, Cisco's put this in most of their hardware, most of their layer 3 hardware and some of their layer 2 hardware with layer 3 code. You can get things like conversations between endpoints out on the same layer 2 network. You cover all the BYOD devices because the moment their datagram crosses any device in the network that Flow's enabled on, we have their conversation. You cover interfaces that are high performance, but you don't have to worry about the interface speed. Flow's a technology that you turn on in the device itself, and it doesn't care what the interface is. So all that worry about cost for deployment based on interface doesn't really exist in a NetFlow environment. And I can cover things like my wide area network and my clinics. These small remote routers are great places to turn flow on. And again, I can get now a full picture of everything going on in the environment from a host-to-host conversation standpoint, and get that end-to-end visibility that I can then utilize to make all sorts of decisions and do all sorts of examination of the environment, monitoring, auditing, and everything else that I might need to do, all with this NetFlow technology, and all without incurring the expense that we talked about earlier from the traditional monitoring. The architecture of flow collection is really simple. Essentially, this is our particular solution. The two devices in the center and the top are all that's necessary to get most of the features and functionality that we generally talk about. Essentially, you need one or more collection engines, depending on how much flow you're producing, and then a management console to wrap up the view of all those collection engines into a single pane of glass. Then you just point NetFlow from your environment up to that collection infrastructure, and you can start getting the reporting. We can also integrate in user information with identity solutions from Cisco, for example, here with ICE, or with this ID 1100 product. And this lets you integrate this solution with your identity environment and attribute flow data and alarms and alerting to individual users, so we can see who was involved in particular flows at particular times. There are other optional portions of this, like flow replication, where you can take care of problems like being able to get flow to a variety of devices, or syslog or traps to a variety of devices in your environment without encountering any limitations or change control issues on the individual devices sending that data. Again, the replicator then becomes the engine that sends the flow into your collection infrastructure. And then there are a variety of sensor technologies you can add to get flow from areas where you normally can't get it, or to augment flow with other information such as timing data and URL that can be very helpful when you are doing an investigation. Typical use cases this can cover, some of these of course I've already touched on, but one is protecting patient data, can enhance data privacy and security policy enforcement if we know, again, what devices in the environment are touching the servers that contain this data. and when they're touching them and how much data is being moved on and off and what protocols are being used. All this stuff is trivial to discover with flow-based technology. We can ensure regulatory compliance with particular legislative laws and efforts by, again, watching for data tampering, theft, and seeing what devices touch what other devices in my environment. We can even establish rules saying, you know, please alert me if anything touches, for example, a particular set of devices besides the ones that are allowed in the policy. I can monitor data from really everything. Anything in the network that crosses a boundary that's giving me flow is going to be monitored. So it's very, very hard for something to escape NetFlow monitoring because almost everything is going to cross some boundary where I can turn flow on. And so I can track critical devices on the network, again, including heart pumps, dialysis machines, drug dispensing machines, et cetera. And I can see, you know, the device, its location, activity, et cetera, all throughout the environment. And I don't have to worry about things like installing agents on devices that perhaps have no facility whatsoever for agent installation. I get this information merely because the device communicates on my flow-enabled network. I can secure, again, the hospital guest networks. I can ensure my BYOD policy is being followed. I can tell where the guests are going. I can tell what protocols they're using. I can tell whether or not, again, the enforcement devices I have employed, whether their enforcement is effective. You know, I can set rules, again, to have the system tell me if any of those policies are violated. I can react very quickly now to network and security issues. Someone calls and says, the network's slow, I need this crucial PACS image, and I'm not getting it, you know, help. I can very quickly go in and diagnose the source of that issue. Flow-based monitoring gives me a rich set of tools for that. You know, my app isn't working. I can go in and tell why very, very quickly. Again, with my earlier example, where's the crash card? Is it on? Is it plugged in? Is it being used by someone? If so, where is it? All these can be done with flow monitoring and, again, optional integrations with things like Cisco ICE identity management. For network bandwidth management, I can ensure the devices on the network are configured correctly, that I'm getting, for example, QoS policy, that I'm expecting that their bandwidth settings on the interfaces are correct. I can track data as it crosses the network, including things like large images and files, and make sure that those applications are getting the bandwidth they need on their links. And then I can enhance the infrastructure. I can augment my investment in existing hardware by capturing flow data for full end-to-end visibility across the network. So I just get more out of what I've already paid for. I can monitor real-time protocols and ensure that they are operating properly, and again, that their bandwidth is being respected, and monitor QoS policies. These are just a few of the use cases that are very, very helpful in a healthcare network. I'm going to go through a few examples here. This will not be a live demo. I encourage you, if you find any of this intriguing, to get with a LANCOPE representative and get a demo. This is a very easy tool for us to demo, and we can show you in your particular environment exactly how this would be helpful for you. The first one here is how are my critical links being utilized. In the tool, I can pull up, for example, this interface status report for a network device, and if I see a device that's showing very high utilization, you know, in the recent past, such as this interface here, I can very quickly pull up a report showing how that interface is being used, what percentage of utilization it's received over time, and show that from a variety of viewpoints, such as raw utilization in the upper right, or utilization by app or service here on these two left-hand graphs, or even utilization by DSCP value. So this is utilization with respect to QoS policy in the lower right. And the tool allows you to immediately click on any of these, dig in to the resulting data underneath and find out exactly who was part of that particular spike that you're interested in. Who talks to my HIPAA host? For example, if I'm, again, trying to you know, comply with a regulatory requirement, I can gather hosts into groups based on their IP addresses alone, and so I can group hosts by any criteria I can think of. And that includes, you know, in this case, my HIPAA hosts. So if I have hosts that contain patient data, even if they're distributed throughout my environment, it's very easy for me to put them in a single object, and with flow monitoring then be able to do things like right-click on them and say, in this case, who talks to them, who are the peers that talk to those HIPAA hosts, and get a list of devices in the environment that talk to those hosts, and very quickly see that, okay, those are legitimate, but what's that host doing talking to my HIPAA host, that internet host out there somewhere? What's going on? And then I can, of course, very, very quickly drill in and find out exactly what is happening with that host that I did not expect. And again, I can also set rules here and say which hosts are allowed and which aren't, and actually get alerted the moment a datagram violates that policy and goes between the HIPAA hosts and somewhere else where it's not allowed. I can monitor very complex relationships in the environment that I really had no reasonable way to monitor before. In this example, I've created a relationship map, and I've put groups of hosts on this map that I want to keep an eye on. So, for example, I've got my Meditech servers in the upper left. I've got automated pharmacies, throughout my hospital environment on the left-hand side there. The bottom left, I got my PACS servers that serve my image data. And on the right, I have groups of hosts of particular concern, guest, wireless, and internet. And I expect data to go between the guest, wireless, and the internet, so that doesn't alarm me. But I'm wondering why so much data is going between, for example, my automated pharmacies and my guest wireless network. That should never happen. So I have the ability with this tool to right-click on that relationship, and remembering that these host groups are independent of topology. Those pharmacies can be scattered throughout a multi-hospital, multi-clinic network, in my entire environment, and I've got them here in a single object. And I can right-click on that relationship and say, show me what's making up that 17 kilobits per second on average of data going between my guest wireless and my pharmacies. Is someone hacking me? Are the pharmacies pinging about? Are they doing things that their manufacturer did not tell me they do? And I can pull up a relationship dashboard and look at the relationship between my guest wireless and those pharmacies and see exactly what's going on. And I can also see, not only the service and applications over time graphs in that relationship itself, but also unexpected hosts in the relationship that are having conversations with those pharmacies, and issues in that relationship. In this case, we have a server response time issue in the relationship, of course, between my pharmacies and my guest wireless. I want there to be issues because I don't want any communication at all happening. But if I was monitoring, for example, my PACS servers to PACS clients, response time issues would be very, very interesting to me, and I would want to go in and start researching them. So this flow-based tool, along with this excellent user interface, gives you the ability to, again, monitor relationships that might be very, very difficult to monitor any other way. I can also monitor, again, just the guests in general. I can just right-click on a group, such as I have here in my relationship map, and say, show me who the top hosts are in my guest wireless. Have any of them been on for a long time? Are any of them hogging a lot of data? Or any of my guests downloading a lot of information, et cetera? And just very quickly get a list of the top guests, in my wireless environment, or the top peers. Who are they talking to? Or top protocols. Are they doing something besides HTTP? Are they trying to touch internal IP addresses, et cetera? All this is easily available with right-click methods on any of our reporting. For monitoring critical servers, here I have a business critical database engine that, again, hosts a lot of crucial information. This can be your PACS server. This can be server servicing the automated pharmacies, manufacturer server that services your infusion pumps, server holding, again, patient data. I can right-click on it and just start asking questions. Show me the top peers. Show me the top applications that this server speaks. Show me what it serves. Show me what services it consumes. And in this case, we're going to look at top peers, and we can see everyone who talks to that critical server. And I can see by the number of bytes who talks to them. And I can see that very quickly, for example, that server is dominated by a single host, and that host is not categorized. So that's a host that is very concerning to me. And I need to go in and try and research that host and see if I can figure out why this host, which does not fall into any of our host groups, so it's kind of a rogue, is grabbing so much data off of that, critical business server. Another example, again, is I can go into that critical server and say, show me what ports this server speaks. Show me what services it offers to the environment that are being consumed, and very quickly get a list. And I might see a number of expected protocols. For example, I see SSH, I see flow data, I see HTTPS, SQL. These might be all expected for that particular server. They might be what the manufacturer told me the server normally does. But then I have this port here, 9998 TCP, that's undefined in my environment. I've not even created a definition for it. So I want to go in and research that, and I can right-click that protocol and get the actual devices that are talking that protocol to that set of servers. So I can very, very quickly drill in and figure out what's going on here. I, of course, integrate identity, and this is an example of the type of data I'm getting from my identity solution. In this case, it's Cisco ISE. And here I can see, users that are logging into my wired and wireless network. I can see where those users are located. I can see their username. I can see when they log in. I can see whether or not they're current or a user that's logged in and logged out. You can see the IP address that they are logged into, or the host groups that host is a member of, the MAC address of the host, the device type, because ISE is doing profiling. So I can see one of those is a couple of those are iPads, the rest of them are Windows 7 workstations. And that lets me ask questions of the environment like, what are Android devices doing in my environment? How do iPads behave? What are my Windows workstations touching? And I can see where these hosts are plugged in. It's kind of cut off over here on the right, but I can see that I've got a number of hosts plugged into this particular switch, and they're plugged into a variety of ports on it. So if I was following a device that had been plugged in the environment and needed to know where it was, I could see not only who, but also exactly where that device is located and be able to track it. And that identity data is then pushed into all of our reporting. So now I can see, for example, all these users in my environment have connections to hosts in China. And if I'm a regional healthcare company, these users, internal users, may not have any reason to be connected to China. So this may represent some sort of worm or botnet activity in my environment. Why are these hosts surfing hosts in China using the HTTPS protocol? So I can very, very quickly, again with Flow, see what's up here. And of course, this data is pressed into all of our reporting. So I can instantly, from any report, answer the vital question of who. Often, in an IT environment, when I'm researching a problem or responding to an alert or alarm, all I have is an IP address. A lot of, our monitoring solutions focus only on the IP. And so then I've got to manually go back and go through my variety of authentication solutions and try and determine who was on that IP at that particular time. And especially in the case of, for example, crash carts or devices at nursing stations where I have a multitude of users throughout the day logging in and out of them, to be able to attribute a particular data flow or alert to a user based on when they logged in and what the device is very critical and can save us a lot of time as we research a time-sensitive issue. And having this data built right in is very, very important. The tool set, StealthWatch, does a whole lot more than this. In fact, it has a lot of automated security functionality that I did not even touch. But I encourage you to take advantage of some of these links and go on and see how we respond to the particular healthcare vertical. There's a lot of other information, again, here on that, including, of course, this webinar is listed. So you can go on and look up this information and take a look at all the different things that we can do for healthcare. Also, again, I encourage you to get with your local LandCope resource. We can help you find who that is and get a more targeted demo that maybe touches use cases that you come up with and get it done in your environment. It's very easy for us to do that and